In this video, we will briefly go over a lesson plan that Tynker provides, understand visual programming at a general level, and complete Tynker's first lesson. Let's go ahead and go through the process of getting to the first lesson. First step is to navigate to the My Classes page if you're not there already. Click on the card for your class. Select lessons from the menu, or you can click View Lessons. Click on the first course, and lastly, let's go ahead and click on the first lesson. I'm sure most of you watching this video have more experience with lesson plans than I do. However, the purpose of going over the lesson plan is to get an understanding of the format and add a bit more meaning to some of the concepts. The first part of the lesson plan are a bunch of code blocks. These are the code blocks that are newly introduced to the students. Every lesson may have new code blocks that are introduced. Code blocks are a set of instructions that the students use to create something. They are also designed to fit a jigsaw puzzle pieces. We will briefly talk about how students can freely create their own projects in another video. These lessons are predefined projects that Tynker has written for students to complete for learning purposes. At the moment, think about these lessons as Tynker being the designers of these games, and your students are the ones who write the code for the game using code blocks that simulate programming. Next, we have our vocabulary. These vocabulary terms are all the basics, and each lesson may introduce new vocabulary terms that introduce new concepts. I recommend you briefly look over these, but we will go over these as we complete the first lesson. Tynker provides you the objectives, materials, and even an exercise you can use to get the students prepared for the lessons. The warm-up is just an example, but if you can find another example that is more relatable or interesting to your students, then go ahead and use another warm-up example. The overall purpose of the warm-up is to get students to think about the set of instructions or steps that is required to complete a task, even the simplest. Some tasks are so simple and we do them all the time that we do not consciously process the steps. However, for computers, the instructions you give them, the order, and method in which they are written do matter. The Getting Started portion of the lesson plans informs us of how to demonstrate the actual Tynker modules and activities to the students. Then we have the actual activities with tips and reminders of how to help guide and facilitate the learning environment with optional activities. It is important to note that although Tynker gives you all the tools, predefined lessons, curriculum, and so on, it is your responsibility as an educator to understand and learn how to complete the lessons yourself, because you will help facilitate, provide context, and guide students into critical thinking. Lastly, important standards for implementation and the answer keys for exercises and quizzes are available. If you find yourself in trouble and do not understand something about a lesson plan or about Tynker as a whole, you will have that yellow help button in the bottom right corner. This is your main source of information regarding anything about the Tynker platform. Alrighty, now let's go ahead and complete the first lesson together. I recommend that you do follow along for this part if you haven't been following along. Now if we go ahead and scroll up and select the first module, we can begin the first lesson. For the first 4 modules, as recommended by the lesson plan, you should demonstrate to students what you are doing using some sort of projecting technology that all students can see. The first module is just an animated scene that tells the students what they will be creating. You can read the captions to students out loud. The next module is a video that quickly shows students examples of what they will be doing in order to get them excited. The third module is a transition module right before jumping into the first task. And now we are ready to begin. The first task is to help Gus, the character, get to the tablet. I will go ahead and click to continue. We are now presented with the puzzle pieces needed to complete this task. Instead of going straight to showing you how to solve this, I will go ahead and more or less cover what the lesson plan recommends we show the students, which is to show them how everything works. If you grab a puzzle piece and place it randomly in the screen, nothing will happen. We are then prompted with a hint. To put back a puzzle piece into our inventory, we simply grab and drag it in our inventory, or in this case, where the trash bin is shown. Alright, now let's go ahead and actually connect the pieces together. As I previously mentioned, these pieces connect like jigsaw puzzles. Once you are ready, you simply press the play button on the bottom right corner to run our game. We now see that Gus actually walked. Alright, we have successfully gone over how to add pieces properly and how to remove them. We still didn't complete the task though, and we once again received the hint that we should connect more than one walk blocks. So what is going on here? Why didn't just telling Gus to walk work? Well, it is because we are only telling Gus to walk once. We need code that will have Gus walk enough steps forward to get to the tablet. So let's just do that. If we count the steps, it will be 4 steps forward to get Gus to the tablet. Let's open our inventory, and this time we add 4 walk blocks. In case you were wondering what the onStart block does, it tells our game that as soon as we run it, Gus should do whatever follows this block. In this case, Gus will walk 4 steps forward. And there we have it. Gus got the tablet this time, and we can move on to the next module. In this next task, we have a similar goal, but there will be 2 actions involved. We must program Gus to walk and jump in order to get to our item. If you read the instructions, it tells us that having Gus jump moves him 2 spaces forward. In other words, the jump command will make Gus jump over 1 space. Try pausing this video and give it 1 or 2 tries to see if you can quickly get it, and then press play again. Alrighty, hopefully you solved that. You see, if we walk forward 2 spaces, we are in front of our obstacle. We then should jump over our obstacle and land on the next space, putting us in front of the item we need to get to and leaving us with 1 more step to go. In sum, we must use 2 walk blocks, then 1 jump block, and finally 1 more walk block. Let's go ahead and move to the next task. This next task seems familiar. We have obstacles in the way and we need to get to our item. We also see that now we have a new puzzle piece with the command to repeat something 3 times. This task is all about identifying patterns. In programming, we never want to have to write the same exact code multiple times if we don't have to. Pause the video and take a few moments to see if you can identify the pattern. Okay, let's go ahead and find the pattern. So I have to jump over this first object, then move forward once, then I have to jump over again, move forward once, and jump over again, and move forward once. We jump over once and walk forward once 3 times. This right here is our pattern. Alright, so let's go ahead and program Gus to do this using our new block. Awesome, we programmed Gus successfully to get to the item with much less blocks than we needed to, and without repeating ourselves. What would happen if we did not take advantage of the repeat block? Let's try it. I'll go ahead and program Gus without the repeat block. And as you can see, our program still works because we still programmed Gus to get to the item successfully. But our first method was much more efficient because we did not have to repeat ourselves, and it is much easier to read and understand. Moving on to the next module. This module is just a transition module into the next task, which will introduce interactive elements. With Tynker, you can create games, and games need interactivity. So far, we have basically programmed a few animations. Now we will learn to add interactivity. We see that Tynker has already provided code for us that gets Gus running in place. If you are wondering how this animation is happening, we just need to take a look at the code. If we look at the code, it says that when we start our program, Gus will wait a set amount of time and then switch to the next costume. And he will continue to do this because we use the block forever, which indicates a never-ending loop, or in other words, an infinite loop. When we learn to identify patterns and not repeat our code, we simply use the block that repeated the code 3 times. This was a counting loop because we told the program how many times it should loop through the same code. And here Gus will switch costumes non-stop. Let me quickly show you which costumes Gus is switching through. You see, all of these costumes create the illusion or animation that Gus is running. Now we are ready to add new code. The instructions say to add the new code, but not connect it to the previous code. We will add what is known as conditional code. It is conditional because it requires something to happen before the code activates. In fact, we have already been doing this. Our code has only been activated when we press play. This is why we have the condition on start. We're telling a specific code to run once we run our program. I'll go ahead and add the new code. And now I will press play and test the code. You will now see Gus moving down, and this is only happening because I am pressing the down arrow key on my keyboard. Now we are to also add the capability to move Gus to the right. We will use similar code to do this. Let's put in the code and test it out to see if we can now move right as well. I see that I can move right using my right arrow key. Finally, we add the rest of the code, allowing us to move Gus vertically and horizontally. Awesome, we are now done with this module. We have now reached the final task. In this task, we will learn how to add additional interactivity. So far, we have only interacted with the character. Now we will learn how to manipulate what Tynker calls the stage, which is basically saying what the background should be like, and even add sound elements to our program. Our first set of instructions tells us that we add a condition that when an actor is clicked, the background should change. An actor is what Tynker refers to the objects or characters that you can add interactions to. Previously, Gus was our actor. However, we have not identified an actor, so the entire area will be the actor. Let's try it out. So every time I click anywhere, the next background switches. Now we need to add music that starts when the program runs. We have learned that in order to do this, we use the conditional onStart block. We'll be adding the forever block, which means that it will infinitely run the code it contains, which in this case, it is to play the music we selected. Let's try it out. Perfect, you see that the music plays automatically, and when I click, the background changes. Alright, let's move on. We see that now we want to add interactivity to the Earth and the alien. To select an actor, I just click on the actor from the menu to the right. We see that when we click the actor, it also changes in the area where our code blocks go. Each actor will have its own code area assigned. Let's add the code to the first actor. And now we click on the second actor and do the same for this one. To better test the sound effects, we can remove the code that plays the music. Let's go ahead and test our program. Great, everything is working fine. The Earth plays music and switches costume when clicked, and the alien switches costume and makes the punching sound when we assign. Alright, let's move on. So now we want to animate the spaceship. We want the spaceship to begin animating as soon as the program runs, so we use onStart. And we want it to run as long as the program runs, so we use forever. And we will change the costume every 0.1 seconds to make the rocket look animated. Let's try it out. Awesome, all the code we have added to the stage and each actor is working. I know you cannot hear the music when I click the Earth, but that is because I should have selected a sound effect instead of a song, since the other music is playing as soon as we run the program. And that completes all the tasks in lesson 1. I recommend you go back and play around with that program and customize it some more to see what you can come up with. I'm sure your students will try to at least make changes to the music and sound effects. Alrighty, and that completes all the modules for this lesson. All we have left is the end of the lesson quiz. Let's see if you can answer the questions correctly as we go through these quickly together before moving on to the next video. First question, we want the actor to play a sound when clicked. Okay, so we need when the actor is clicked, conditional, and the play sound code. Awesome. This next question asks us how to change the costume as soon as the program starts. We mentioned a few times that to do this, we need to use the onStart block, and then we need the next costume block, which is the code to activate it. Great, now we are asked how we change the actor's costume when it is clicked. Well, we need the conditional when actor clicked and the next costume. The next question wants us to find a true statement. Let's see, right off the bat, A is not true because we know that onStart is just a condition and does not activate any code in particular. B says that the play sound block can be used to play music. That definitely sounds right, but let's go through the last two. C says that the play sound block can be used to change how an actor looks, and we know this is clearly wrong. And lastly, D says that the next costume can be used to play music, which we know is also clearly wrong. C and D were used to trick us, but the answer is B. Awesome, let's move on to the next question. This next code is asking us to find which code block activates code when an actor is clicked. It doesn't tell us which code to activate, which means it only wants the conditional block, which makes B the right answer. The next question gives us the code and wants us to describe what happens. A says that the sound will occur when program starts, and we know this is wrong because onStart is the block that activates code when the program starts. B says that the actor will make a sound when it is clicked, and that is exactly what our code shows. Question 7 is similar to the previous one. A says that the actor will play an animation, but our code doesn't have anything about an animation. B says nothing will happen, but our code says that when the program runs, the costume will change, so this is also wrong. C says that the actor will change costumes each time the program runs, which is correct. Awesome, and now our final question. This question wants us to select the block that will make our program play a drum sound. C is the only code making a reference to a sound block, and the sound selected is a drum, so this would be the right answer. Awesome, we're now all done with our lesson. In the next video, we will quickly go over creating programs from scratch and concluding this crash course series.